You know, when you think about a refinery, some of the most dangerous jobs can look surprisingly routine. So today, let's talk about one of the most common maintenance tasks out there, something that happens every single day but carries a massive, catastrophic risk: the line break.
Just think about it. In a plant this massive, you've got maintenance and modifications going on all the time. Line breaks are just a constant, routine part of keeping the whole place running. But just because it's common,
Well, that does not mean it's simple. In fact, it's one of those activities that has the highest potential for things to go very, very wrong. If you get this wrong, the consequences are, well, they're truly catastrophic.
All right, so let's get into it. How do you take a job that's both routine and incredibly high risk and make sure it's done safely every single time? Well, it all comes down to a super rigorous, step-by-step process.
First things first, let's get our terms straight. Line break sounds simple enough, right? But the definition is actually incredibly broad. It's literally any time you create an opening in a system that's designed to be completely sealed.
and this really shows you just how broad we're talking. We're not just talking about taking a big pipe apart. Even just loosening the bolts on a flange, opening a valve to the air, or disconnecting a simple little hose, it all falls under the line break procedure. Why? Because they all carry pretty much the same risks.
So what's the big deal? Let's break down exactly what makes this seemingly simple task so incredibly hazardous.
Okay, number one, you have to assume that whatever is inside those pipes is nasty stuff. We're talking about things like corrosives that can burn you, flammable liquids, or toxic gases, where even a tiny bit of exposure can have really severe health consequences.
Then you've got the sheer force involved. These systems are running under immense pressure. So an uncontrolled release isn't just a leak, it's basically an explosion of energy that can cause serious physical injury and, of course, widespread damage.
And of course, where you have flammable materials, you have the risk of fire. A sudden release can easily find some kind of ignition source, and just like that, a routine maintenance job turns into a major disaster in a split second. And as if all that wasn't enough, you still got the more, let's say, conventional physical risks. You're working with heavy tools, a lot of times in tight spaces, so falling objects and pinch points are a constant worry, just adding another layer of danger to the whole thing. So, to manage all of these hazards, you need a system. And the absolute foundation of doing any kind of work safely in a refinery is the permit to work, or PTW. Let me be clear, nothing happens without one. Now, this permit, it's not just a piece of paper. It is a vital communication tool. Just look at this process. It goes from a request and a risk assessment all the way to authorization and finally acceptance by the actual team doing the work. The whole point is to make sure every single person involved is on the exact same page.
What's so important to understand here is that the permit is the single source of truth for the job. It's the master plan. It spells out everything, from the specific hazards and the control measures to the exact isolation points. If anyone on the job has a question, the answer has to be on this permit.
Okay, so we've got our permit. Now, how do we actually get ready for the job? Well, the preparation is broken down into 5 critical steps, and they have to be followed in order.
This right here, this is the heart of the procedure. And I want you to notice something really important. The actual break is the very last step. Everything before it, the planning, preparing the site, decontaminating the equipment, and then verifying it's safe, it's all about systematically getting rid of risk before a single bolt is even touched.
Now, decontamination is probably the most critical phase. This is where you make the equipment physically safe to work on. It starts with what's called LOTO, that's lockout tagout, to make absolutely sure no energy can get into the system. Then you drain all the hazardous fluids. And finally, the whole system gets purged, usually with an inert gas like nitrogen, to push out any dangerous vapors left behind.
But before anyone even picks up a tool, there's one last safety gate, the final verification. The team has to physically walk the system and confirm everything. Is it clean? Are all the locks and tags from the LOTO in place? Do the pressure gauges read 0? And this is so important, are we standing in front of the correct piece of equipment?
So, only after all those preparation and verification steps are totally complete can the team finally move on to the actual execution of the line break. And even then, the work is done with extreme caution.
The key word here is vigilance. You don't just rip it open. You crack the flanges slowly from a safe distance to let any trapped pressure escape.
You've got spill containment ready to go, you're constantly monitoring the air for any bad gases, and you are in constant communication with your team, calling out every single step.
And the job isn't over just because the pipe is open. Not even close. Bringing a high-pressure system back online safely is just as critical and just as dangerous as taking it apart in the first place. Bringing the system back to life, well, it requires its own rigorous checklist. It's this whole meticulous process of reassembly, removing any temporary isolations, cleaning up the area, and it all leads to formally closing out that permit. Only then, and I mean only then, can the equipment be safely and officially handed back over to operations. But look, despite all these precautions, you have to be prepared for the worst. Everyone on the team needs to know exactly what to do if something goes wrong. Activate the alarm, get to your evacuation point, and report the incident. Knowing your role in an emergency is absolutely vital.
This quote really just sums up the entire philosophy, doesn't it? It's the guiding principle behind every single permit, every procedure, and every decision that's made out in the field. The work can wait if things aren't safe, period.
Because, at the end of the day, safety isn't just a set of rules on a page. It's a culture of collective responsibility. It needs every single person to stay focused, stay vigilant. So knowing all this, does this level of procedure maybe change how you think about routine maintenance?